Hi, in this video I want to take another look at the same example we looked at last video. So we had the function y of x equals x squared minus 4, and when we drew its graph it was a parabola that went through the x-axis at -2 and +2, -2, +2, and we found the definite integral. We found the definite integral from from 2 to 3, and we got 2 and 1/3. We got 2 and 1/3 units squared as expected, because we can see this area is of course positive. This time I want to take a look at a different definite integral. I want to find the definite integral from -2 to 2 of y of x, so x squared minus 4 dx. Well, what on earth would that be? Here's -2, here's +2, so I guess we'd be finding this space between the function and the x-axis. Let's go ahead and check out what number we get. So, as last time, we put our antiderivative without the constant term in a box. So x to the power of 3 divided by 3 minus 4x. And this time we're finding the definite integral from -2 to +2. And so if we go ahead and substitute in our values, we get 2 cubed divided by 3 minus 4 times 2 minus, same thing but with -2 this time, -2 cubed divided by 3 minus 4 times -2. Running out of room. Okay, that is equal to 2 to the power of 3, so we got 8 over 3 minus 8, 4 times 2 is 8, minus, well, -2 to the power of 3 is -8, so we're going to be minusing -8 over 3, so that's the same as plus 8 over 3, and then minus, and then we got -4 times 2, so that's, sorry, -4 times -2, so that's minus -8. Okay, so that's plus 8. Wait, is that right? No, that's not right. We're minusing -8, so we're minusing +8, so that's -8. Okay, so what do we got here? We've got 16 over 3, because 8 over 3 plus 8 over 3 is 16 over 3, minus 8, so minus 16. That's the same as 16 over 3. What's 16 times 3? 16 times 3 is 48, so minus 48 divided by 3, because 48 divided by 3 is 16. And so that's the same as -32 over 3, which is -10 and 2/3. What the heck? So according to the calculation we just did, this area is -10 and 2/3. Well, that's silly. That's just silly, because area cannot be negative. Area is positive by definition. So what did we actually calculate? What did we actually calculate? Well, let's recall how we calculated the antiderivative before. So we had our function, this is y of x, we had our function y of x, and we made some rectangles. So we were making rectangles like this, and the height of this rectangle, the height that we were using, so the height was actually y of x, and y of x plus h. So that's what we did all of our calculations based off, y of x and y of x plus h. And in the example we used, it stayed above the x-axis the whole time. It never went below the x-axis. So our rectangles always had, well, the value of y of x times h always gave the area of those rectangles. Suppose instead this time that our function actually goes below the x-axis, like what we've got here. So this is our function y of x. And now, what we actually have here is, suppose we take x equals -1. Well, y of -1 is -3. Y of -1. So if we were going to calculate our rectangles in the same way before, this distance here was our h value, and then the height that and when I say height, I mean in quotes, height of our rectangle would have been y of -1, which was -3. So when we calculated things, we're actually going to have the negative of whatever this area was. We would have the negative of whatever that area was. If I wanted to calculate the positive area, I would have to flip this thing up the other way. I would have to flip this thing up the other way. I would have to have negative y of x. So this is negative y of x this time. So that would actually be 4 minus x squared. Oops. 4 minus x squared. Now, whenever we do anything, whenever we use our rectangles to calculate that antiderivative, those complicated calculations we were doing before, it's going to have a positive height. So this one would be y of -1, which would actually be equal to +3 this time. And so everything we did would give the positive area. So, negative y of -1 would be that value, because y of x was equal to x squared minus 4. Negative y of x is equal to 4 minus x squared. Better write that down. Negative y of x equals 4 minus x squared. Positive y of x equals x squared minus 4. The graph we have right now is of negative y of x, so don't get confused by that. Okay, so everything we would do from x equals -2 to x equals +2 of the graph of negative y of x is actually going to give us the positive area. So to find the positive area, the calculation we would have needed to do was actually the the definite integral from -2 to +2 of the function negative y of x dx. But integration is linear, which means we can actually pull that negative out to the front. So that's the same as negative times the antiderivative from -2 to +2 of y of x dx. In other words, it's negative times the antiderivative from -2 to +2 of x squared minus 4 dx. And so that is equal to negative 10 2/3, which is equal to 10 2/3. And I should put the units squared because it's area. So, and if you're a bit confused by that, observe here that negative of the integral from -2 to +2 of x squared minus 4 is equal to the integral from -2 to +2 of 4 minus x squared dx, which is exactly this area here, this blue area under our curve flipped upside down. So you got to be careful. This pink area is not negative 10 2/3 units squared as we thought it was. The pink area is actually the negative of that, so it's 10 2/3 units squared. Okay, thanks very much. See you guys next time. Bye.